Get started. Okay. Good morning, Bangkok. Sawadee krap. Is that right? Hope so. My name is Russ Scammell, and I'm a product evangelist for Unity. So I cover Southeast Asia, India, Australia, and New Zealand. And a bit of a disclaimer beforehand. I'm not a developer at Unity, so I didn't make the WebGL system, but I have a lot that I like about it, and I wanted to share with you guys. So I'll take your technical questions at the end of the talk, or you can email them to me, but I'll probably need some reference from the devs to get back to you. Yeah, so just to let you know. But we're going to share a little bit about what we've got with WebGL and what's coming, and the state of it, yeah? So let's talk about, is the sound okay? Can everyone hear me all right? Yep. In the back okay? So, okay. So let's talk about publishing to WebGL in Unity 5. And to begin, let's see why we're there. Why are we at WebGL? And let's look at a short history of web deployment in Unity. So this was one of the first platforms we did, actually, a long time ago. Unity built for web player, right? And that was part of Unity since 2005. Web player was a browser plugin that would basically allow you to run Unity content. So how many of you guys, can I do a bit of a survey of the room? How many of you develop for the web already, right now? Okay. And how many of you have built on web player? Okay, cool. And how many of you have tried the new WebGL preview? Okay, cool. So, okay, good, interesting. So, with the web player, you could basically get all your Unity content running on any web browser that would support our plugin, right? So, released with Unity 1.0, first technology to bring hardware-accelerated 3D graphics into the browser. And it really is a cool way of playing games on the web. Yeah, very, very nice stuff, very good graphics, very high fidelity. Give you some kind of vague numbers about it. The last time we counted it, we had nearly 400 million installs. That still grows. We had many partnerships to do with the web player. Some browsers would include it. When you installed, you'd get the web player as well. We got good working relationships with people like Facebook, and we got, you could do integration into Facebook via the SDK. And it has a significant presence in Asia. I think at last count, we're looking at something like 45% of web player usage in Asia. Now, here's where it gets interesting, right? So the Unity web player is distributed as a browser plugin. And browser plugins, so for those of you who aren't aware, these are shared libraries that users can install to display content that the application itself can't natively play, yeah? Can't natively display. So for a long time, this is the way we did a lot of stuff, yeah? So we've all seen Flash, we've all seen all of these things. It was a way to get content onto browsers. But now, for a long time, browser plugins, that was the only way, right? And in recent years, HTML5 has come up, and there's a lot of new technologies. So actually, WebGL in Unity is a combination of HTML5 technologies and WebGL, yeah? But we refer to it as the WebGL build. So in recent years, HTML5 and other open web kind of concepts, standards have made such formats available to everyone on browsers without plugins, right? And that's cool, because no one wants to download a plugin, really, if you can help it. In some cases, you can't download a plugin. You're locked in a system or within a network in some organizations. No, you're just locked to whatever you have. So plugins have become legacy technology, yeah? Browser vendors are starting to steer away from them. They are considered security risks. Yeah, there's a vulnerability there. You don't know what's in it. Someone else wrote it. right? You have no idea what you're running. So, and they're also kind of opposed to this idea of the open web, which is where we're all headed, right? Open web. And then, so the big one for us also is Google. So how many of you have Chrome, latest Chrome? How many of you use Chrome as your browser? Really? That's fewer than I thought. How many of you use Firefox? Yeah, Firefox. Okay, cool. Awesome. So, IE, really? Someone? No? Opera? Safari! Who's on Safari? Okay, cool, yeah, very cool. So, Google has announced that with Chrome 42, essentially, unless you know how to turn the flag on, you don't have NP-API plugins anymore, yeah? So, that's no web player on Chrome. So, other vendors are going to kind of make this harder as well. There's more mouse clicks between you and playing a plugin. You can kind of see where this is going. So we come to WebGL. Okay, so how many of you know what WebGL is? Have you any idea? Okay, cool. So, great. So let's do a little bit of intro on that. WebGL it's a JavaScript API. Stands for Web Graphics Library. Yeah. So it's for rendering interactive 3D graphics within web browsers. So you can do this without plugins. Yeah. It's based on OpenGL ES 2.0. The current thing we've got running in Unity's build is we are calling it WebGL 1, right? So look forward in the future to WebGL 2 tech. Some of that is really cool. If you drop by the Mozilla website, you can check out some of that. The demo we've got running on their website is quite impressive. I mean, the kind of stuff that's happening in WebGL 2. So it's an open standard. So again, this is in line with where we're all headed. So how did we get to WebGL in Unity? Okay. So I'm going to share a little bit about the Unity culture, what we do at Unity. So we're a very chilled out company in many ways. A lot of people work on what they want to work on. And that's how we're structured, and that's kind of what's made us work the way we do. We still have that startup mentality that we had many years ago, and we carry it forward even though we've got so many customers now. And we're trying to kind of bring people into the fold as well, so we can all learn together. And one of the ways we do this, so even when we're crunching to get Unity 5 out of the door, even when we're working really hard to get you guys new features, right, that we've already announced, we have something called a Hack Week. Yeah? So Hack Weeks allow our developers some time. We take a week. We used to do it about between 1 and 3 times a year, depending on what we're doing. Yeah, and we all go away somewhere, get out of the office, right? Get out of the whatever, the normal run-of-the-mill stuff that we do, and everyone puts an idea on a board, something they've been thinking about, a new technology they've been following. Yeah, something they want to experiment with. Because this is the R in R&D. Yeah, this is where the sparks happen. And if people are working on something that they care about, that they really want to bring to the masses, that's where it all comes from. So we had a couple of guys who were interested in WebGL, and this is 3 years ago. Yeah. So this is the story that I've heard, and again, there are variations on this. The one I heard was, so they spent a week, right? They wanted to see what's possible, right, with WebGL. Spent a week on it, hack, right? Figure out what can we do? How can we get this stuff to display in a browser? How can we get Unity to run, on this technology? Spent a week. At the end of it, they got a browser that displayed the color blue. Yeah. Cool, right? So here's the thing, though. It was the right blue. Yeah, it was the correct blue. It was the blue that you got in the background of the camera, right, in the Unity viewport. So we were like, right, cool. Next up, spinning cube, right? So we took it from there. We kept going. We added more and more hack weeks to this because there was obvious potential here. And then, so we were using, I think it was an LLVM that we had ourselves developed. And then some engineers from Mozilla were like, hey, we know what you're doing. We've heard what's happening there. It's kind of cool. Let's work together. We've got some cool stuff as well. So they joined a hack week. And by the end of that hack week, we had some pretty good stuff running. So it wasn't scripts yet, but I believe we had a camera flying along a path, and that was happening in the web browser, like just a few weeks in. So the potential for WebGL was really something we could see. This is something we wanted to be in, and we started production on that. So let's talk a little bit about how it works. So WebGL being a JavaScript API means all your code needs to be in JavaScript, right? So just to get a gauge of the room again, how many of you guys are coders? Who writes code? Okay. And how many of you use Unity already? Okay. And how many of you write in Unity script? Right. And how many of you write in C#? Excellent. Okay, cool. So this is where we needed to figure out what to do with this. We needed JavaScript, right, everywhere. So there's two basic things we needed to do. And we started off with that camera on the path because it meant that we could test Unity engine code first, right? So we did Unity engine code. We needed to convert that into JavaScript. And then we went to the actual user scripts. And that's a slightly different path, yeah, because that's C# to JavaScript. So to achieve this, we had to use a combination of tools that were already available and some new technologies that we had to invent as we went along. Yeah? So EMSCRIPTEN. This is one of the tools that we use in our compiler tool chain and in our compiler chain. And it's essentially it's an open source project started by Alon Zakai of Mozilla. It is an LLVM, right? So this is a low-level virtual machine to JavaScript compiler, right? So that's pretty cool. Takes your LLVM bit code, right? So this is stuff you generate from your C or your C++. In our case, we're using Clang. And then we compile that into JavaScript. Now that means we can run that stuff anywhere JavaScript runs. In most cases, you're talking about web browsers. And we use EMSCRIPTEN to convert our engine code to JavaScript. Now the other technology, right? So we've got EMSCRIPTEN that does our engine code to JS. But what about user scripts? So for this one, over the past few years, our scripting team has developed a new code compilation technology that we call IL to CPP. And I'm sure you've read more about this in the blogs. This has become something interesting for us in the company. It's driving quite a lot of decisions moving forward. So what is this? What is IL to CPP? So this takes your .NET bytecode, and we generate corresponding C++. Now, once we have C++, we can go through JavaScript, right? Get to JavaScript through EMSCRIPTEN. But we do it in a special kind of way, right? So we want to generate a certain kind of JS. So we use ASM.js. So ASM.js, anyone know what that is? ASM.js? Yeah. So ASM.js it's a subset of JavaScript, right? This is completely valid JavaScript, but it's statically typed. That's one of the big things about it. Now, this is a good thing because it means that your JavaScript engine on your browser can ahead of time compile, and it can compile into well-optimized code. Something you can't do with JavaScript vanilla, yeah, the normal stuff, the full set. So that's what it looks like, right? pretty straightforward, or not. So there's many steps. It's very interesting. But basically what we do is we get from the C# script, we compile to CLR bytecode via MCS, we change the CLR bytecode to C++ via IL-CPP, compile that to an LLVM with Clang, convert that to JavaScript, make sure that's asim.js JavaScript using EMSCRIPTEN, we get our JavaScript, we optimize it, we minify it. Okay, nothing difficult. Very important steps though, along the line. For example, we'll talk more about the optimized and minimized JavaScript later. Cool. So, how do you actually build a WebGL project in Unity? 2 steps, switch platform to WebGL, preview, hit build. Done, right? So that's the basic thing. Again, we're trying to take the difficulty out of problems, so it is just another platform to us, and we need to treat it that way. But of course, there are things you need to consider, and we're going to talk about those later. But what does this get you? So when you hit build, what do you actually see? So when you build and run a project in WebGL, right? So like when you do it in Windows or something, you get an exe, but with WebGL, you get a couple of things. And it's important to know what they are. So you get your index.html. This is your HTML file where we embed your stuff, right? All your game and the player. You're going to get a .js file. That's going to be the same name as your project. That's the code for your player. You're going to get a mem file. So this is a binary image. So we use this to initialize the heap. More on that later, why we do that. And the most important thing of all, .data. That's your game, right? All the cool stuff you've done, all your assets, all your scenes, right, in a file. Now, you're going to get also some supporting JavaScript files. And there's some ways you can customize this stuff so that you can have different error messages, the kind of things that you want your users to see. You can also use these files to change the way your deployed project displays, right? So we provide 2 basic templates, but you can actually add to those. So if you use Unity's build and run command, right, you're going to get a file that is temporarily hosted on a local server, local web server, and we're going to run it from a local host. So this avoids all the security restrictions. So it's pretty fast to iterate, to get a project running. You don't need to upload this anywhere. You can just run it on your machine. Okay. So a reminder, this is still WebGL preview, right? And the reason we call it that, or in some cases early access, is that there are some unsupported features. And there's a combination of reasons why these things are unsupported. So how many of you have developed for the web, done web applications, or you've written websites? Yeah. So does everyone enjoy web standards? They're fun, aren't they? Yeah, there's so many. It can get very complicated. And the thing about, so the whole switch, for example, from plugin to pluginless web, that's one of these things that we have to pay attention to closely. And the reason some of these things are supported or unsupported is some of it is work we still have to do. So again, we have it out there as a preview. We want everyone using it. It's available to everyone with the new Unity 5 structures. So we want your feedback, because we need to see how it's doing, how it's running, what you guys are using it for, what the use cases are, and that will help us make decisions about it moving forward. We're also finding ourselves in an interesting position, and I've spoken to some of the guys who developed it in our core team, and some of them have been around for a long time. They've been with Unity since the really startup days, since we were just a small studio, just making a cool engine, and you could check in dirty code, right? It didn't matter. You could just make stuff run and, cool, it's fun, no worries. Now we've got 4 million plus developers using our stuff. So we realized that, hey, you know what? We're driving a web standard here. We're actually working with guys like Mozilla, who are trying to get this stuff out into the hands of many people, doing some pretty cool stuff. So we need to get other people to see the way we're doing it and get them to, for example, employ ASM.js in more browsers. So let's talk about some of these unsupported features. Runtime generation of substance textures, that's probably not coming anytime soon. That can be complicated. Movie textures, no. Networking is there to a certain extent. You can get going with WebSockets and WebRTC. We've got some samples of that in our documentation, so I would take a look at our manual. There's a lot of good information on there. We're updating it a lot, very, very frequently, because we're getting a lot of good feedback, and we're making a lot of changes as we move forward. There's no support for webcam or microphones. Anything that's advanced audio is going to be something you want to test. Audio on the web is famously difficult and doesn't necessarily work in the same way or the way you'd expect across different browsers. Script debugging, yeah, not really. So, but you can do things like get stack traces and stuff. So we're working on making that easier. No threading. This may change. We've heard some interesting new stuff coming up. It's not in the current build, but we've heard that some people are working on some interesting technologies for threads. So any .NET features that require dynamic code generation, no, that's not going to be okay because we are AOT, and no runtime GI, but we want it. So that's something we're looking at getting. So cool. So let's take a look. So I've broken down the next bit into kind of the options and the settings that you can look at when you're building a WebGL build. And it's good that a lot of you guys haven't, so you can kind of think about these things while you're building, because these decisions are actually critical to what kind of build you get and what it's like to iterate on a WebGL project. So the build options. Build options in WebGL include a setting for optimization level, right? So this is after you've switched to your WebGL platform and you're looking at the different things you can do. One of them is slow, right? So you've got optimization level slow, fast, and fastest. Now for slow, we don't do an optimized build, right? This means you get a much faster build time, but you're not going to get the performance you expect. But this is definitely what you want to do when you're building, right? So this means much tighter iterations for your team when you're in development. Fast produces optimized builds, so that's in between the two. And then fastest, we make the maximum number of optimizations, everything we can do. But yeah, you're going to want to have a lunch appointment to escape to, because that's going to take some time. And I would recommend, or we generally recommend at the moment, this kind of thing for final releases or towards the end of development when you're building release candidates of your project. So one of the important things you definitely want to look at, and doing it in the right place, is the development build for WebGL. So interestingly, checking the development build checkbox builds a development build. Right, obviously. So what does this mean, though, right? So how many of you guys use the profiler? Right, so now we can all use the profiler again, right? This has made me very happy, personally, because I talk about the profiler a lot. And it means that, with Unity 5, everyone's got it. You can all look at your code, you can all look at your projects, and you can tell, where your bottlenecks are, what's going wrong, how long are things taking. And you can profile with a development build in WebGL. So that means that you get profiler support, you get the dev console for errors and things like that. Now, very important to realize, development builds are not minified. So minified is when you get your JavaScript and it's all like big and readable, kind of readable, but we shrink it down into something that's really, really small. We remove lots of space, things like that, yeah? So development builds are not minified. So the generated JavaScript is actually kind of human readable, kind of, but it preserves function names. So when you make this, you've got something that you can use to get stack traces that makes sense. So this is cool. It's good for dev. means a larger distribution, and it's human readable, again, worth repeating. So don't distribute your dev builds, right? Because this is your whole game exposed to the world, right? It's JavaScript out there, open, right? People can read it. So, yep, very important. Other things to look at. So WebGL has, there's a small section that it uses in the player settings. This is common to other platforms as well, with some of the other platforms. And that's the stripping level pop-up. Now, we may change the UI on this moving forward, but currently it looks like the other platforms. However, the difference between disabled and strip assembly, strip bytecode, use micro, and all that is that as long as you choose anything that's not disabled, we're just going to strip everything that you don't need, right? We don't distinguish between the 3 stripping levels, so choose any one of them, and we'll do stripping for WebGL. So what does that mean? So this is also quite important. So I was talking to a few devs who are already using WebGL, and depends on how well you use Unity. So for example, if you add a component, any component that uses the physics system, we're going to include the physics engine. Now you may not want that, because again, you're making a web deployment, right? So that means removing colliders. That means removing rigid body, yeah? That can have a huge impact on the size of your deployment, so something to consider. If your game is simple enough, or you guys have the time and the resources, you might want to write your own code that does this kind of thing without incorporating the entire physics engine. You probably don't need it in many cases. So many games use it by default because it's there, it's a Unity feature, but you can also just as easily write some basic collision code yourself, and there you get better build size. And the stripping will work to your advantage. All right. So there's a whole new section of publishing settings. So this should actually say publishing settings, but it's in the player settings dialog. So with WebGL, there's something very important that you need to consider, and that's your heap size, right? Your memory size. So there's a field in the publishing settings where we look at specifying in megabytes how much memory the content should allocate as its heap, yeah? So this is something quite important to think about. You need to think about the configuration that your audience is on, what they're using, and then you'll know what kind of level to choose for this. And also your project, how much content are you trying to squeeze into your build. So if you set this number, so here by default we've got it set at 256. If you set it too low, what happens is the heap that is set aside for your project becomes too small. So if you set it at 256, but you try to load in 300, 400 megs of stuff, you'll just get an out-of-memory error. That's all you're going to get. The thing will fail, and your loaded content can't fit. Yeah, it's a bit like running out of RAM, something like that, right? It's like trying to get stuff running on old phones. Yeah, you had to really think about, this is fixed. I can't move this. What can I do? Now, too high on the other end. That's interesting. So one of the things I tried to do when we first had our WebGL out was I wanted to see if I could get it to run on a device. Yeah, because that's kind of strange. Unity build running on a device, running on a browser, running on a device. Yeah, and we don't support it, not at the moment, but it's kind of the obvious step that a lot of people will try. And it runs. And we detect that it's a mobile device, and we actually give you a warning, and we say, haha, you're on your own. We don't support it yet. Coming soon, maybe, we'll see. We've got the bigger, more serious PC and Mac browsers to look at first. But the way memory works on devices is very interesting. So what you need to do here is make sure that you don't set this number, your memory size, too high. If you do set it too high, the content will fail again, right? And the reason for this is that we're trying to allocate memory to the heap. We're trying to ask the device, hey, give us some of your memory, right? And there's actually not enough memory around. We can't make the heap big enough for your project. So you're going to fail due to insufficient available memory on the device itself. But yeah, worth playing around with, definitely something that we're looking at in the future. Also, exception support. This is improving a lot in our 5.1 build. This is something we'll be happy to share with you soon. The enable exceptions pop-up in the publishing settings has